Hello everyone. I've got a new and honestly not very interesting or exciting video about how to draw Lewis structures of atoms and ionic compounds. All right, so a Lewis structure was come up with by a guy named Gilbert Lewis. He's quite interesting. That'll be a topic for a different time, or you can just Google it. He developed a model of a way of drawing models of molecules that we've since named after him, called the Lewis structure. So to draw a Lewis structure of an atom, all you have to really do is count first how many valence electrons does that atom have, and then draw them in, one on each side first. So how does that work? I'll show you. So step one, to do that, all you have to do is look at your periodic table and remember that it's organized by how many valence electrons an atom has. So the first column, the first group here, has one valence electron. Second column, second group, two valence electrons. Skip the middle section. We don't really need to do that right now, and it would be a slightly more complicated topic. Come over here to group 13. That has three valence electrons, four valence electrons, 5, 6, 7, 8. So if you can count 1, 2, 3, 4, 5, 6, 7, 8, you can figure out how many valence electrons something has. Second, draw them in, one on each side first. So let's pick an atom at random. Carbon. What's its Lewis structure? Well, draw carbon. It has four valence electrons. Draw them in as dots. 1, 2, 3, 4. And that is the Lewis structure for carbon. Nitrogen has 5. 1, 2, 3, 4. And then the fifth one can go anywhere. It doesn't matter. Let's put it right there, 5. Fluorine, it has 7. 1, 2, 3, 4, 5, 6, 7. Again, it doesn't matter which one had the single electron. Any side is perfectly fine, whatever you're feeling good about at that moment. All right, so that's it. That's all you need to know for atoms. So how do we do that for ionic compounds? Well, it's not much more interesting or complicated. It's just that for ionic compounds, remember, cations have lost electrons and anions have gained electrons. So let's draw the Lewis structure of sodium chloride, for example. So sodium is over here. Sodium is in the first group, so it has one valence electron. We'll put a dot. Chlorine is over here in the 17th group, so it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. All right, so what we're saying happens here is that sodium actually loses this electron to have none, and chlorine gains that electron. So the sodium ion is just drawn as an Na+. The chloride ion is drawn with all 8. And by convention, we put brackets around that in a negative. You'll see even chemistry teachers leave off the brackets from time to time or very often, but that is the way we're sort of supposed to draw negative ions with their electrons with brackets around them and a charge outside of the parentheses. It doesn't really get more complicated than that. Except slightly more complicated if you have a 2 positive ion. If you have a compound like magnesium chloride, you don't have to draw this first step showing where the electrons came from. You can skip right to what you know the ion charges are going to be. Magnesium is down here in group 2, so it has 2 valence electrons, but it's going to lose those and become a 2 positive ion. Chlorine has 7 valence electrons, but it's going to gain 1 each and have a -1 charge. So you can skip right to that point. You don't have to draw in the electrons and show the transfer, and just write magnesium 2 positive. And then you have a choice. You can either draw both chloride ions separately, and you kind of get to choose where you draw them. It's not super important. like that, or you could just write Mg2 positive and 2 Cl negatives. That's it.